of companies know that AI is the next thing and they want to get into it, but they don't know why or how. Right? I just want AI, give me one of those. Right? In the same way that other companies some years ago, they said, I need one of the DevOps, just give me one. Database power, we all know that, coders know that. And I think that AI is hiding away data sources. Changes of any kind, new software, new processes, new technologies, we trade data.
Welcome to the first episode of the DevOps Dialogue in 2025. It's good to be back after a bit of a break. Today I'm joined by Marc Cluet. Marc, why don't you introduce yourself for our audience?
So, I'm Marc Cluet. I have been doing DevOps in one way or another for many years. I was lucky enough that I started doing WebOps back in 2009 when I arrived to London.
Before it was cool.
Yeah, kind of keep study through with school still. I had a very opinionated and very inspirational CTO back then called Nick Ferrier, and he got us into automation and WebOps and all the rest, and then it became DevOps, and I was right in the right place at the right time, which I'm really lucky and happy about, right? So yeah, I've been doing it for quite a while. Before that, worked in 4 different countries, been a bit everywhere around the world where they would allow me. And then I moved to the UK and I have been here ever since. Doing DevOps, I help with the community any way I can, because I'm always of the opinion that we all are here because somebody at some point completely out of the blue and without expecting anything back has helped us in one way or another. And I think that when you're in a position where you can actually help back, it's really important to. So I started London DevOps with Matt Saunders back in 2014, just as a way to give back to the community, and also because we both really sucked speaking in person. It was really horrible at this, and it was a good way to keep practicing and keep getting better.
Yeah, your name is synonymous with DevOps for me. You're one of the first, alongside Matt, you're one of the first 2 people I've met in this space, and you've been active in the community for a very long time. So how has the landscape changed over the last 10, 15 years, and where do you think it's heading?
That's a great question. The DevOps has changed radically because the objectives, or the first objectives that DevOps had when it started, they all have been accomplished in a way. It was all about fostering that communication, fostering that culture, releasing faster, releasing safer, making sure that different teams understood and sympathized with the position and the pressures of different roles, especially between Dev and Ops, because as we know in the past, it was pretty much like throw the grenade over the wall and see what happens in a way. But now things go faster, things go better. The cloud, of course, have immensely helped with that as well. And DevOps has a culture, and it has gone so far and it has done so much that at this point I would say DevOps have a bit of a crisis of existence. And you can see that because, for example, it was really cool to call yourself a DevOps engineer in the past, and now it's a platform engineer, which, to be honest, should be the right title. But all these agile methodologies and all these DevOps methodologies have become so much the day-to-day that now you can see all the enterprise business versions of it happening. And yeah, it's difficult to know where to go next, right? A lot of the DevOps forefathers, or the initial people in these, people like John Willis and Patrick Dubois and Mark Miller, they are going more and more towards AI. And I think that's where DevOps will go, right? Because AI is in a way affecting so many layers of IT and our daily lives, directly or indirectly, that it's one of the ways that this can go, and I think this is one of the ways that this will go.
There's a massive stigma against using DevOps as a job title, to the point I've even had like hiring managers in my career saying that they would not interview a candidate if they call themselves a DevOps engineer, which is bonkers, right? But let's talk about the evolution of DevOps as a job title, right? So it started off as a sysadmin, then progressed into a DevOps engineer. In the last probably 3, 4, 5 years, that's slowly becoming extinct, and the platform engineer has taken over. What's next?
That's a great question. It's a really difficult one to answer in the sense that I'm also a believer that calling yourself DevOps something is an anti-pattern. I'm a strong believer in the book that Matthew Scatton and Manuel Pace wrote, DevOps Topologies. And they said in that book, and I fully agree with them, that DevOps is an anti-pattern, right? If you have a team that is called the DevOps team, you're actually excluding the teams that you want to transform. So having a DevOps team for a very short time is great. Having a DevOps team as an antagonist to the dev team and the ops team is not great. Where this will go, platform engineers specializing more and more. I think that one of the things that DevOps and automation did really well is to take all sysadmins, including myself obviously, one layer up, right? We were as sysadmins racking servers, cabling networks, dealing with data centers, and now with DevOps and the cloud and automation, we deal with the next level above, operating system automation, operating system install, configuration of servers, clusterization of servers, and with especially containers and Kubernetes and container orchestration, serverless, microkernels, you name it. We're going again one layer more, right? We're going one layer above again into what I would say is starting to be the management of the developer experience, the management of the deployment process. And I think where this is slowly going, because operating systems and networks will still be necessary, but that will become jobs that will be more and more automated as they are already. And you will have teams that deal with them that will be reduced in size, because the same way as a sysadmin in the past used to deal with 20, 40 servers, and that's it. And then with automation, they could deal with 200 servers in one go. The same will happen, right? All the layers below will reduce, and the majority of the people will go one layer above into the developer experience, deployment experience, orchestration. And I think where this is going, a lot of platform engineers, when you say platform engineer now, they will do Kubernetes, they will do Shell, they will do Golang. If they are really on top of their game, they will do Python as well. So it's becoming more of a coding orchestration job rather than dealing with physical servers and changing hard drives.
I think as a byproduct of a DevOps engineer is to an extent, automate themselves out of a job. Yeah. As bad as that sounds, I think it is happening to an extent. What's going to happen to those engineers, and particularly those that perhaps don't know how to code properly? They can't build production code. Will there be a place for them?
I think so. The problem with this, and this is one of the problems that you always find when you do transformations. I've been doing several cultural and technical transformations in the past, and that was always a question. Like, we have all these engineers that have been working here for 20 years. They don't know how to code. They don't know how to do anything else than what they do right now, right? So for me, IT in general, computer science, I've always said that it's like being a doctor, but we are lucky enough that we don't kill anyone when we're not up to date in our knowledge, right? But we need to keep updating and refreshing our knowledge. We need to keep being relevant to the market. And all these people that I found in the past, that of course they were very comfortable in their position, they were happy to be in a place where they could keep doing the same job again and again, and they didn't have any need or didn't understand that they needed to evolve. One of the things that I did, and this is what brought me into managing people in a way, because I became very passionate about this, is trying to help them get on, trying to help them upskill and get into something that they actually enjoy. And a lot of people, they are reticent to change, but they so reticent to change, and this happens in all different aspects of life, that they will handle daily pain or daily boredom or daily anxiety in order to not deal with the effort of change. And once you show them that change is easier than they think, and it's easy to upskill, I would say it's relatively easy to upskill into Kubernetes. It looks really scary, it looks really complex, but at the end of the day, it's just the same things that all system engineers, network engineers, platform engineers have dealt with their whole life, with just different names. So it becomes becomes easier once you get that and you understand that, and having the right help and the right people at hand helps you push in that direction. So what I think will happen with them, coming back to the question, is that some of them will resist the change, because that always happens, and they will be able to find jobs in different parts of the industry, but these jobs will become less and less frequent, up to the point where they can either retire. And I've seen some people literally go into farming from computer science.
Wow.
Because they were like, you know what, I'm done with these, I don't want to keep upskilling myself, I just go into something a bit more handy in that sense. And all the people at some point will realize and will start upskilling and will start doing new things and will become again someone with relevant skills that can go into the market and can find any position they want, because we are lucky enough that we're in a position that we can actually find jobs with relative ease.
As a leader in this space, as a hiring manager, what would be your advice for the sort of up-and-coming platform engineers, perhaps at the early stages of their career?
There's two things that I always say when I find someone that wants to start into platform engineering. One of them is that this job, as any job, is 99% perspiration, 1% inspiration. In the sense that there's people that approach and say, oh, there's good money in IT, I would like to change my job into IT because, you know, they pay well. It's like, this job is really frustrating. And it will frustrate you beyond what you think can be frustrating. And at inconvenient hours as well. So it's not that you can go 9 to 5 and leave. The machines are running 24/7. So you might be bothered 24/7 if you don't automate yourself out of that. If you do, great. If you don't, then yeah, you will get paid at 3 a.m. Or you get paid while you're at the cinema and you'll have to leave the cinema in order to deal with something, which is not great, right? And you will spend maybe 5 days trying to solve a problem that at the end was a single line somewhere. It's full of frustrations, but if you're someone that has the patience and the push to go and see beyond that and be able to do whatever is needed for the job, then definitely this is a job for you. And then after that, if this means that you have the right attitude, and for me the right attitude is 90% of the job. Having the knowledge, it's 10%. Knowing a specialism into networking with eBPF, with the Linux kernel, it's something that will get you extra money and will get you extra jobs, but it's not what will make you stay on the job. So I always tell them, it's like you need to come in with the right attitude, because this job will be about sucking eggs a lot of the time. And when that happens, a lot of people quit. So if you're one that wants to stay and enjoy this, and even when it sucks in a way, excuse my French, you will stay and you will keep doing your job, then absolutely you have a wonderful career ahead.
And what's your thoughts on university degrees?
University degrees, I think they are great in the sense that you have two schools, right? You have the Peter Thiels of the world that say that university degrees are completely irrelevant in computer science, but then of course they do dubious stuff as fund political parties and stuff like that, so I'm not going to get into that. But I would say computer science degrees give you the basics that you need in order to do this job. And by the basics I mean foundational computer science, foundational mathematics. Will this help you in your day-to-day? Maybe not. Because the day-to-day is more about, as I said, that patience, that perseverance, being able to keep going. But what it will give you is the perspective and the peripheral knowledge in order to know exactly what you're doing. And you can see that difference. Like there's a lot of people in this computer science industry that do not have a university degree, and they are perfectly capable and really talented people. But when they find an issue, they will get stuck in the issue because they don't have the extra knowledge of that foundational computer science, unless they have done that on their own. So there's some stuff that will happen, and someone with that foundation will go, yep, that's exactly the CPU making a bottleneck in the kernel that is affecting the memory paging. And someone else will go, how do you know that? It's like, because I I've seen this enough times, and I know how computers work internally to know exactly why this is happening. And a lot of people inside the industry don't know that anymore because the job has been abstracted up many layers, so we're getting less and less close to the machine. It's something that is incredibly important, especially when we're talking about very high availability, very high demand systems, right? Could be a trading system in a bank, or could be an ads system like Google Ads or something like that. There's very little margin for error. You need to take the maximum of the resources you have. And knowing all of that, knowing how a CPU works, how memory works, how the kernel works, becomes more and more important in these things.
Just to play devil's advocate, is it worth accruing maybe up to 50k of debt just to know the kind of theoretical knowledge and basics, or is there perhaps a better alternative to gain that knowledge without accruing so much debt?
So, to give you full perspective, I didn't finish my computer degree. Fortunately for me, I was in a country where acquiring debt for university degree was not a thing. So I could go into university and start learning, and I had zero debt. In some other areas, like if you get English philology, and then you have 50k in debt because you studied English philology, it's not a great place to be in because I would say it's more difficult to be able to repay that debt back. But in computer science, I would say 50k in the computer science degree would be something that if you play your cards well, you will remake and get back in 5 years. If you play your cards well, because it gives you a competitive edge, and that competitive edge of being able to know all the basics, but also when I hire someone that has a university degree, I know that they are someone that has gone through the sucking eggs phase, right? Because they've been doing that for 3 years, 5 years at uni. Because the same as the industry itself, doing a computer science degree is a hard thing to do.
Do you prefer candidates from a degree background or those who finish university?
I always look, when I'm hiring a candidate, I always look for the attitude. That's the thing that will make it or break it for me. Someone with a university degree tells me that they have the perseverance to go through 3 years, 4 years, 5 years, do the long hours, do the code assignments that are completely useless sometimes. But they have gone through all of these, and they have come to the other side, and they are in a position where I know that I can give that person something really hard to do, and they will keep going through it until it's done.
Like a laborious task. Yeah.
Exactly. So where another person, I might give them something like that, but I have no way in an interview to check that they have the perseverance to go through and finish a task. I have zero idea when I'm interviewing someone. So that gives me a bit of a clue. I try not to be biased in any way because, to be fully honest, some of the best people that I work with do not have university degrees. But some of the best people I work with do have university degrees as well, right? So it's a mixed bag.
Throughout your career, you've worked in both tech companies as well as sort of large financial enterprises. What are the main differences, and are there perhaps any similarities?
There's some similarities. I would say the main difference is, for me, between enterprises is the speed of change, right? Especially for risk-averse companies like insurers, banks, government. It's really difficult to get to a position where you get enough speed to be able to change things quickly, because the whole business is designed to not do that, because the whole business needs to be stable. Where if you're in a retail industry or if you're in a startup, then you can apply that agile paradigm that I think it was John Willis that said that if you're not scared, you're not going fast enough, right? And in those industries, it's easier to do that because at the end of the day, if you cannot sell a jumper on the internet or you cannot sell a train ticket, it will come back, right? Some of them might be lost, but the majority of people will try again. Where if you do a bank transfer between two banks, or you try to claim to your insurance, or you are in an emergency and you need to call AA or the RAC to come pick you up, and something fails, that's huge reputational damage, right? So it's not great. So I would say the main thing between both is, especially for regulatory stuff, you need to be very conscious of what you're doing and the legal implications of what you're doing. So it's closer to being a doctor in a way, because someone can sue you if you do the wrong thing. Where if you're in retail, if you're in startups, in some ways it's a bit more happy in some ways, but in some other ways also you can easily get yourself in a rut, because there's a lot less checks, there's a lot less validation of what you do. So you can easily get yourself to a point where you blow up something by mistake. Right? Personally, I've done that. I'm not going to say where, but it happened.
Maybe off camera.
Yeah.
Any similarities you can spot?
There's a lot of similarities in how the development process itself works. The development process is pretty much the same everywhere. The main difference is the impediments in that development process, right? But developers, they work the same way, they act the same way, they want the same things. The deployment process, development process is literally the same all across. As I said, the difference is, as I said, in one of them, you will be able to go faster and break things, which we all, as a community and a society, establish that break things and move fast is not the greatest paradigm. Breaking things is still not great, whether you're in a startup or whether you're in a big company. But the thing is that then you can move faster and develop faster. Where, I said, if you're an insurance or a bank, that's not your business. So you want to make sure that whatever you give to the customer, it's reliable, soundproof, bulletproof, etc., etc.
You said engineers do very similar things regardless of the industry they work in. It doesn't happen very often, but it happens more often than I would like to hear personally, that an engineer says, I really don't care what company I work for, I don't care what industry I'm going in, I don't care what the size of the company is, I've got a job to do, and that's what I'm there for. If you heard that as a hiring manager, would you ever hire someone like that? And do you think, it's a valid viewpoint?
Yeah, absolutely. It is fully valid, because software is software. And if you've seen how companies have changed, we have companies that were selling flights, companies that were selling train tickets, or were selling clothes. And now these companies, they define themselves as an IT company that sells flights, a computer science company that sells clothes, because IT and computer science have become essential to any company and the operations of any company. Right? If you're selling online, you need an online platform that needs to be maintained by someone, and that's your business now. Or if you say plane tickets online and you have a sale, same, right? So at the end of the day, I think that one of the important things about the attitude when you're hiring someone is that attitude of I don't care. On one side, it can burn someone up, because they might walk into something without fully knowing exactly how the work environment is and what kind of things might be frustrating of that work environment, because different companies and industry will have different frustrations in that sense. But at the same time, it's something that person as a hiring manager would highly value, because if you don't care, you care about the challenge, you care about the project, you care about how can we make this better. And that's what I'm looking for, right? I want someone that when you are trying to push for something, even if it sounds impossible, goes like, yeah, we'll find a way, let's go.
I think that's very refreshing, because the vast majority of clients, regardless whether they are insurers, big banks, or whether they do, something meaningful, not that insurance or banks don't do that, but, they ask recruiters to find people that are really passionate, they really want to work in this company. But I think your take on this is much better. It's much more realistic. If every candidate tells you, I've woken up and I feel like I want to work here, obviously you're being lied to. What have you learned from working in kind of fast-moving tech companies that now helps you to navigate the corporate environment?
What I have learned mainly is what is the right amount of risk and pain that any company is willing to take. Because changes of any kind, new software, new processes, new technologies, we create pain. And this pain will be either upskilling, will be anxiety in what will happen with our jobs, because now we need to know this thing called Python that nobody else knew in the company. Or we trying to do things in such a way that we might actually break the main database of the company, and business will not operate for the next 30 minutes. Right? So it's understanding what is the right speed of pain and what is the right speed of change for companies to evolve. And different companies have different speeds, and it's not even by industry, it's cultural. So it's really difficult to assert unless you are in and you are seeing exactly what's happening.
What effect is AI having on the industry, and how do you think it's going to reshape the platform teams?
That is really tough to answer. There's several areas in these, right? And I don't want to go really long into these, but I would say that at this point, and this is my personal opinion, obviously, is that a lot of companies know that AI is the next thing and they want to get into it, but they don't know why or how. It's like, I just want AI, give me one of those. Right? In the same way that a lot of companies some years ago, they said, I need one of the DevOps, just give me one. Right? There's some areas that I think that will be really highly effective, like coding assistance, automatic detection of patterns, observability, monitoring, all of these will really hugely help. But there's no real way yet, or there's no real integration that makes it incredibly easy. It will become costly and really difficult to do for the time being. And I would say the area where it's helping a lot already, it's in copiloting code. Mm-hmm. The biggest issue is that it's twofold. In one of them, if you're a company that you're a risk-averse company, by copiloting code, you might be introducing defects in the code and things that you don't really want there. And the other part of that, of course, is all the coding style, because there's a lot of companies, for example, Google, Facebook, etc., they have coding style guidelines. And it will be more difficult to enforce and maintain those with automatically generated code, because it doesn't follow any of that, unless you train your AI model into all your code you have with your coding guidelines. But that, of course, will reduce the effectiveness of being able to generate new code. Important part of this, and this is something that I'm literally quoting Patrick DeWantis, who has an interest in AI. He has said that AI will make the job of the code developer something that changes from having 60% or 70% of the time writing code and 30% of the time debugging and improving the code, to something where it will take only 20% of the time to write the code, but then the other 80% will be understanding what the code has been written, the AI code, how it has been written, and debugging that code so it works. Because AI at this point, unless you have really, really important optimized prompts for this AI model, whichever one you choose, will write code in a way that will not be exactly what you want, but will be really close to what you want. So it's an assistant in a way. It will help you write code faster. It will even help you write code if you don't know how to write that code, but then the maintainability of that code reduces dramatically. So I think that the cost value of AI at this point is really heavily skewed towards a lot of cost with not a lot of value, but that will change in the next 5 years. In which ways will change, we don't know yet, but I think that the big opportunities on these are in monitoring, observability, and code assistance for sure.
With such increased automation when it comes to building code, do you reckon you would need less software engineers, or do you need to retain kind of relative amount of engineers on the team to be able to validate the code that AI has built?
It depends on the size of your company, and it depends on the complexity of your code and the complexity of what you're doing. If the size of your company is really small, it will accelerate, you will need less developers, right? So in this sense, AI will help significantly startups and very small companies to validate model and what they want to do is effective, spending less money on developers. But once you get to a certain size, the amount of developers that you have will not change, because you will spend more time debugging, more time integrating, which is something that AI is not capable of yet, or that high-level integration, understanding how every single part of this application or this business works. It's all that context that humans have that AI can't have yet, will still need to be done, right? So it will not reduce the amount of engineers or coders. It might change the role or what they do, but I don't think it will reduce the amount of people there.
I know you're a big proponent of green DevOps, and we actually have a very timely example in the form of DeepSeek that you can achieve a lot with limited resources. What repercussions do you think this is going to have on the industry?
I think that AI has become such an arms race, and it was an arms race where countries and private investors were throwing money into the black hole. And this black hole was eating resources. You can see how NVIDIA stock has gone up incredibly, and how the industry has advanced, especially for GPUs and everything that is related to TensorFlow, vector flow, and all the rest. It has advanced at a gigantic pace because it was needed to fill that gap in the industry. But all of this also consumes a lot of carbon, right? It consumes a lot of resources. And you can already see that something as data centers is a significant percentage of the power consumption in every country, in every developed country at least, right? And this trend will just become heavier. I don't think that the AI will be an accelerator, but it certainly adds to the problem, right? And as this problem was what I call the fallacy of infinite resource, right? Every developer thinks that there's infinite resource behind what they do, or I would say most developers, I would say every. And they code in a way that they don't care how much they are consuming, because it's fine. There's always more resource available. There's always more to consume. The problem is that the real world repercussions of that is that we're burning more and more carbon. We're burning more resources to keep all this code running, keep all these services running. And it becomes really ineffective. But as the market wants more and more of this, they sink in more and more money, more carbon, more pollution. And DeepSeek is breaking the market so hard. It makes me happy in a way, because it's breaking the market so hard, because it's again the human capacity to overcome challenge. And overcome challenge in the same that DeepSeek was created in a world where the US heavily sanctioned China didn't have access to the latest and greatest power-consuming GPUs from NVIDIA. They had versions that were less powerful and had less resources. So what did you do when you have limited resources and you still need to develop this? You get creative. And that's when I think humanity thrives. And we've all been in that position, right? I've been in companies where, in startups where they said, okay, our budget for cloud this year will be $10,000 and we want to serve 1 million customers with that, right? And you have to deal with that and you have to do the best you can. But that's when you get really creative, and that's where human creativity comes at its best. And I really hope that with DeepSeek being so brutally less consuming than the rest, this will send a signal to OpenAI and to all the rest of AI companies that they need to go in that direction, reduce your carbon footprint, but while still being effective and still giving the value and result that you need.
Apart from being cash-strapped, what strategies could a company or a manager deploy to make their team members care about how much compute, how much power they use or waste?
So one way that I've seen that, especially with FinOps, is that every single team are given us a budget for the year, and they compute in budget, and they can see in real time how that computing budget gets consumed. And I think that's a really good way, right? Create that scarcity, even if it's artificial scarcity, you give them, like, you have only these to run. And that makes things a lot more effective, because otherwise, I said, infinite resources, we can go ahead and develop as quickly as we can without any fear of consequences of how much we are wasting. And I've seen that happen in companies. The perfect example of this would be everybody that is advocating for lift and shift to the cloud. I know that this is the same debate that we had for the last 6-7 years, but there's still companies that do lift and shift, and then they are suddenly surprised when cloud costs are incredibly high. I was in a company in the past that they had a cloud budget for the year of a certain number. I think it was something like $1 million for the year, which is not insignificant. I wish somebody would give me $1 million right through. I would be perfectly happy running that. And they did lift and shift, and the $1 million went away in a month. Right, so
no unheard of. Yeah.
That's when you get the scares like, whoa, okay, we need to actually manage this better. But a lot of companies do that for budget reasons or for profit, but I think that if governments, for example, started doing those carbon offsets and push that straight into companies, not only into big pollutant companies as they do and they should keep doing, right, but into IT companies as well. Like, this is all the carbon you can consume this year, use wisely, right, and push more cloud providers, as for example Google is doing and Amazon is starting to do, provide preferences for availability zones and data centers that are fully powered by renewables instead of powered by carbon or powered by petrol, powered by gas, and start declaring publicly which ones are clean energy versus which ones are carbon offset energy and which ones are really burning the planet, and be able to choose consciously where you're going and how you are spending that money and spending those resources.
Do you think the general public cares? I mean, look what's happening in the US, right? Complete U-turn on the Paris Agreement. I think European Union is going to follow suit in no time. Does your average Joe care about whether where the energy is coming from is a good source or not?
I don't think most people do. Some people that are conscious do. Some countries that are conscious do. For example, Switzerland, when I was living over there, your power bill would come with, this is the percentage of electricity on your bill that is clean energy. Right? I think that's incredibly important. The average people don't, because it's too abstracted out, the same way as people don't know that by eating meat they're actually killing an animal. If you ask some people, they will not even know that that's happening, right? And that's why there's people that decide to not eat meat, which I, of course, fully respect. But we are too abstracted out from the natural resources in general. So it's very difficult for us to imagine where all things come from. That when we buy a new telephone, actually we are affecting the mining industry in Nigeria and other African countries that is creating political tensions, right? So all these things, we are abstracted away and they're hidden from us. So it's very difficult for us to make the right choices. But big companies have bigger impact. The most polluting companies have bigger impact than the majority of individual people do. So it's very important as a company that you contribute, because you can contribute bigger and faster than trying to change the mind of millions.
What are some of the concerns and considerations that companies should keep in mind when it comes to AI?
The main concerns, at least for me and my position, would be data, right? Because data is power, we all know that, governments know that, and I think that AI is hiding away data sources. So I was reading something today which was really fun, that OpenAI was accusing DeepSeek of stealing data from their model to create their own model. But OpenAI did actually crawl the web and steal data that it has copyright and has trademarks without any care at all. They just got all of it, right? And the more AI gets into our day-to-day, the more our data will be exposed and will be recorded and will be saved. And I know that we're doing that for the sake of practicality, and because it's effective, it's practical, makes our lives easier. But I think that data will become more and more gold in that sense, and will become more and more something that people trade on. So we need to be very conscious of when we're investing, especially as a company, in AI models, where our data lives, how is our data stored, how are we dealing with data, because we have due diligence for all the consumers that are using our products, that the data will not be suddenly somewhere in China or sold to some third-party company without our explicit consent, right? And we need to be very careful about that.
Apart from AI, what are some of the most exciting emerging technologies in tech right now?
I would say there's three areas that always fascinate me. The first one, AI. I've been following AI for the last 20 years, and it has gone bounds and leaps. The other area is data storage. It keeps being incredibly effective at storing more data in less space, and we're starting to hit physics problems. We're starting to hit the limits of what physics can do, and nonetheless we still find ways to create something incredible that is still within the bounds of physics but still stores more. And the third part is batteries. Batteries is something that has evolved at a lesser pace than the rest of the industry, because it's really hard to create more effective batteries, but also it's really dangerous to create the wrong batteries, right? Because you can literally catch fire. So it's really important to do it right. Those are the areas that I'm normally always fascinated and keep following. As for CPUs and microprocessors and GPUs, they still are following. The law of duplication of transistors every year and a half, and it's something that keeps happening. Even as I said, we are getting very close to limits of physics, so I'm really keen to see where that is going as well.
What's the biggest misconception in the industry?
The biggest misconception in IT is that, I would say, the buy versus build. And that's one that anyone that is listening to this, I'm sure, has suffered at some point. It's the temptation to build something is so big that a lot of companies are maintaining a lot of software that is 70% or 80% the same as a piece of software that you can buy off the shelf that gives you these many more things. And these contributes as well to green computing, right? Because by rebuilding the same code again and again, you are literally creating less effective waste, and you are, in a way, spreading the talent around that could be focused on, hopefully, an open source contribution towards a piece of software that can be used by humanity in general. The build versus buy for me is that this misconception. A lot of companies have made that mistake. A lot of individuals, including myself, we have made that mistake as well. And I think very carefully now when I create something, is this something that I could actually have as an open source project, or is something that I could actually pay someone to support that gives me what I need?
I'm getting a feeling with all this experience you've got under your belt, you're now leaning towards buy over build?
It depends on what exactly. I will buy where I can, because, as I said, it's a good way to not only reduce your costs, but also you can contribute back to something that is being effective and beneficial to everyone. And at the same time, it helps you hiring more engineers, because engineers out there, they will learn open source products and enterprise products that are available, but they will not learn the thing that you created inside your company that nobody else knows about, right? So the upskilling and the onboarding of people becomes more difficult as well.
There's a lot of resistance towards learning custom-made tools, because there's only one place you can use them, right?
Exactly, and that's in a way what I call the Google problem. So Google has created all their own tools, and they're incredibly good, incredibly engineered tools. They're amazing. But the biggest problem is that when someone has been working at Google for the last 10 years and they go into the market, none of the skills are usable in a way. They are usable up to a point, right? Because the tools inside Google, they're very similar to the tools that are out there. But at the same time, they don't know enough. So I've seen in the past people that have come out of Google and they said, I don't know how to do this, but at Google, we do it this way. Again, and I'm sure you have heard about some people that did that. I think it's not as bad as now as it was in the past, but it went to a point where Google was so custom that it was really difficult then to get out of it, which it's a lock-in trap, right?
Ironically, it's not that easy to place someone from big tech because firstly they come with a massive paycheck, right? And secondly, their experience is fairly custom. It's not always applicable to every environment. What's the last thing you changed your mind about?
When we're talking about DevOps, and especially about DevOps culture, I'm becoming less and less tolerant to some areas. It's not because I'm getting old.
Old and grumpy.
A fact of life. But it's mainly because I see the dangers and ineffectiveness of some of them. And today I was actually having a conversation about what it's called the centers of excellence, right? You've heard about this company creating a center of excellence for that company. And I was talking with a friend some time ago, and he made a really good point. I mean, it's the point that I now copy from this friend. And he said, center of excellence, it's divisive because you are creating a center where people are excellent, which means that people outside that center are not. So it's divisive. What's the motivation for someone that is not in the center of excellence to listen at someone that is self-appointed excellent at something, right? There's no real motivation to listen to them. So I'm more and more in favor of what I call the centers of enablement. It's still COE, it still fits the letters, but when you do a center of excellence, in reality you're doing a center of enablement because there's a skill gap in the company or there's a need for a transformation, and you're enabling the group, you're enabling the company or the engineering community to be able to advance in that way. So you're enabling them to go forward. So I'm more and more in favor of that, and that's one of those that when I heard Center of Excellence in the past, I was like, oh yeah, fine, it's okay. But the more I hear it, the more counterproductive and the more isolating that I feel that it's making people.
Great, yeah. I think it's a great way to look at it. I'm going to steal it as well. Is there anything we haven't spoken about that you'd like to talk about?
I would say I love trying to contribute as much as I can to the community, and everything, if you have a chance as an engineer and you have the time and you want to contribute to your local community in any way, even if it's, as I said, going to the local school and teaching kids how to code on your free time, or giving a talk in a meetup that someone else can learn something about and change their career. I encourage everyone to do that because it's something that I think makes society and community better, right? I would ask anyone that come to the meetups, give talks, don't be afraid. The worst thing that can happen is that you give a talk and people think that they disagree with you, and then we create a great debate, right? So don't be afraid to talk in public, don't be afraid to help in any way you can, because that makes us as a society better.
You've got to push yourself, like, step outside of your comfort zone.
Yes.
If you're not a great speaker, you're not going to become a great speaker if you don't try.
Exactly, and I've seen my evolution throughout the years. When I started speaking, I was terrible, absolutely terrible. I was deer in the headlights moment, and I would be adding words in between and the and doing pauses and repeating things. It was pretty bad, and that's why I started in a way. Not that was right. It's like I want to give something back. I want people to know more about this, but also I want to make sure that I force myself to do something that I'm really uncomfortable with, and be able to do it up to the point where it becomes second nature, because that's the only way to improve.
Mark, thank you very much for your time, for your pragmatic approach, and for sharing your wisdom with us. And thank you for watching and listening, and stay tuned for future episodes.